Hi, everyone. Thank you for joining in. So I've got a really interesting sort of story about what happened in Ghana. So around COVID time, we had this challenge of energy crisis where price of electricity really shot up, fuel prices went up, and the site host, Ghana Broadcast Corporation, did really ask us to increase the rental quite significantly to a point where we were really thinking about closing the service. So that just made us think about what can we come up as a solution to fix this problem. So we had three big challenges in Ghana. Number one challenge was that the power supply from the utility grid was really unstable. And that meant we had to rely quite heavily on diesel generators. In some occasions, we've even had 24 hours of power outage. So the power situation is really bad there. So that really had a strain on our operational cost. So the way it works for the BBC in Ghana is that we pay a fixed amount of site rental, and then on top of that, we pay for utilities like fuel and maintenance. So during COVID time, they had some energy crisis. So supply from the grid was really unstable, and we had to rely a lot more on the generator. That also made us think that BBC, because it has a 2030 goal to go completely carbon neutral, that really made us think that we should go for a sustainable solution. So solar was the first thing that came in our mind, because not only does it reduce the carbon footprint, in some cases it just makes it zero, and in other cases it can really reduce it. So in Ghana, we have got two broadcast sites. One is in the capital, Accra, and the other one is in Sekondi Takoradi, which is about 4 hours drive from Accra. I was fortunate enough to travel to Accra February this year when the project kicked off. So we came up with different sort of solutions which would work for us. Initially, we thought that an off-grid solution would be the way forward, but then we looked at the payback period, and that really made us think that is that the best solution? Plus, the broadcaster, Ghana Broadcast, was also really interested in knowing if they could also benefit from solar. So then we came up with the solution of hybrid system where the whole site benefited from our off-grid solution. Initially, it was designed for one transmitter, but then we thought that it's best that everyone gets benefit from it. So that really worked like a win-win solution for everyone. That allowed not only to reduce our payback period, but also ensure that everyone who's on site can reduce their carbon footprint. And the other good thing about Ghana is that it's at the forefront of accepting renewable energy. A lot of other countries in West Africa are not at the same level. What it means is that, similar to the UK, they do have the provision for smart meters where you can sell the electricity back to the grid. So that really makes it a lot more attractive as an investment proposition. So I'm just going to briefly talk about how a solar system works. I've chosen a DC coupled system, which is the most simplistic sort of solution. So over here, we've got our solar panels attached in a string. Generally, you can get anything between 200 to 500 volts DC in a typical system. They're connected in a cascaded fashion in series, and then it goes over to the charge controller. So what a charge controller does for a layman person is simply like a transformer. It just transforms the high voltage to a lower voltage, which is manageable for the battery, so that it can make use of that. Depending on the sort of battery you're using, it could be 48 volt architecture, or could be 250 volt, 500 volt, 1000 volt architecture. So the system that we have chosen here in Ghana is a 48 volt battery architecture. So this charge controller, what it does is that it converts 200 to 500 volts to 48 volts. And depending on the state of charge of the battery, it can increase the voltage to speed up the charging process. If it really approaches closer to that level, what it does is it reduces the voltage so that the system can still make use of the power but not charge the battery. And because it's a grid connected system, so we have the grid system connected to the inverter. So during daylight, all of the power that's coming in from sunlight is being converted from 48 volts to 230 volts at the circuit breaker level.
Our grid system here in Ghana is not stable, actually. That even made a lot of people give it a name, doomsaw. Doomsaw is like a name that is coming from the Akan language in Ghana. It means that there is a power outage, unpredictable power outages that comes, and or it can also be means that there's a schedule of power outage because the power supply to the entire Ghana is actually not enough. So sometimes they have to put some areas off to be able to power some areas, or they have to shut down some plants to work on them. There's always a frequent power supply here in Ghana. Yes, so actually we don't have a stable power supply here in Ghana.
So I'm just going to briefly talk about the hybrid solution. How does it actually work? So we've got three sort of scenarios I thought it would be interesting to know more about. Number one scenario is that we have a power cut during daylight time. Let's say assume it's midday and the sun is shining and you're getting peak performance. So what happens is that if you get a power cut during that time, the system just carries on as normal and it just keeps on charging the battery. So that's number one scenario. Number two scenario is that you get a power cut just right after sunset. So that means that the battery will still have lots of juice left in it. So that we have designed it such a way that it should hopefully give you about a couple of hours of backup. But in scenario three, if let's say assume that the batteries are completely exhausted, what would happen is that either, actually, if the batteries are exhausted, it will automatically ask the generator to kick in. But we've designed the system in such a way that the generator will also charge the battery, just like a hybrid car. So in 1 hour, you can get 2 hours of backup. We've got about 270 kilowatts of generator on site in the capital city. And the load is about 55 kilowatts. So that allows us to charge the battery really, really quickly. So in 1 hour, it fully tops up the battery, asks the generator to switch off, and gives us 2 hours of backup. But if the power cut goes beyond that, then it could request the generator to kick in again. But in that way, we are reducing the generator usage quite significantly. And that's also saving a lot of fuel. Okay, so how do the commercials really work? So we went with different sort of permutation, ranging from off-grid to grid-connected. Because in the grid-connected, off-grid solution, we still had to pay site rental, which was still quite significant. So what we thought was, let's strike a commercial deal with the partner. And in that way, we could give them electricity, and the benefit that everyone gets, that could be paid off towards our rent. So it's like a double benefit. So what we did was we encouraged everyone to sign a contract in which we could allow everyone to benefit from it. So this hybrid solution allowed everyone on site to have non-stop electricity. So there's no need for UPS, no need for anything else. The system itself can take care of voltage fluctuations and all other sort of problems. And the great thing about that is it reduces the maintenance interval for the generator, because typically you need to do generator maintenance after every 250 hours of usage. With this sort of approach, we have prolonged it quite significantly.
There were some few challenges because it was a high mountain building. We have to move the materials, but because of the high mountain, the van cannot go up. So we have to move them bit by bit. Another challenge has to do with the ground, because the ground wasn't leveled and there was a lot of stones. But at the end of the day, we were able to find out some solutions around them, because we have to move some of the stones and then cast concrete because it's going to be a ground mount. And then, even though with the challenges, we actually have a good experience there, and we're able to execute the solar system.
So this is like a top view from the drone for the two sites. Although it doesn't cover all the solar panels, that's just one part of it. We've got a total of 111 kilowatts of solar panels, these are about, you can say 70% of the panels for the capital city. And this is the other city, Sekondi Takoradi. We've got built multiple of these carports. So it keeps the car cool and at the same time generates electricity. So it's an efficient way of utilizing the space. So in Accra, the typical load is about 56 kilowatts. That includes radio services like BBC, Radio France International, 2 radio stations of Ghana Broadcast. And we used to have Voice of America, but because of Donald Trump, the service was plugged out. So, and we also have a TV station here. It's an analog TV station that's been powered by the solar system. So all in total, we've got 56 kilowatts of load on average around the clock. So the battery is about 150 kilowatt hours. So you can say about 2 electric cars, roughly give or take, sort of battery storage. And that typically gives us about 2 hours of backup in the evening hours. We deliberately retain some level of battery charge so that if there's a power cut, the battery kicks in as a primary source rather than the generator. For Sekondi, we don't have any TV station. It's just primarily a radio station, so the load is significantly lower. As you can see, it's just 15 kilowatts. And the battery storage is about 60 kilowatts. So that gives us at least 3 hours of backup. So from a carbon intensity point of view, this site is more sustainable, I would say, because it relies even less on the generator. But because the load is lower, the investment required for this one was lower than the capital city.
We have a lot of sun in Ghana, but it's not just about the sun. It's also about the temperature. And then in the solar system, when you have a high temperature, you are not likely not to get the best performance. We should not always just depend on the sunshine, thinking that we'll have our best peak of panel production or the solar performance. We should also look at the temperature as regards to that. Another one is the rainy season. Currently, the rain is on and off, but it's been raining, I think the past 2-3 months, it's been raining back to back. So it's also one of the challenges that we face here. If you are designing a 50 kilowatt peak power system, and because of the weather climate, you have to factor in that and then add maybe an excess or increase your production just to kind of like cater for the losses that you'll be encountering due to weather climate. Yeah.
So this is a typical graph for our Accra site, which is the capital. So it follows like a bell curve, or around midday you get peak performance, and then it kind of drops down, and then in the evening hours we retain some charge just for backup. And I'm just going to show you a live demo of what our system is doing. So this is live data that's coming in from Accra. As you can see, we are generating right now 20 kilowatts. So I think it's overcast. But just a few minutes ago, it was producing 70 kilowatts. And we've got the other twin city, Sekondi, next to us. That's currently producing 38 kilowatts right now. And the load is 18 kilowatts. So yeah, the benefit of this thing is that we can have a proper sort of audit of how the system is performing, and we can show the data to our partners. And after a year, we can tell them that, look, we have done what we were expecting, so we should be here for free. So if you can switch back to the slides. So the big question here is that in everyone's mind, would this work in Europe? And the answer is yes. Although in winter we do get really short days, but that can quite easily be offset against our long sunny days in summer. And surprisingly, the performance of solar panels in the UK is better than Africa. I was really shocked to see, because when we did the pilot in Ludlow, which I'll go to the next slide, our peak performance was nearly at par with the theoretical limit. That means that because in summer the temperature is closer to the standard sort of 25-degree temperature in which the lab testing is done for these solar panels. In Europe, we can sort of achieve that because our air temperatures are much lower. So we have witnessed 100% performance in the UK, which is great. So in Europe and in places like Germany, you can sell your electricity during summer season and you can get a lot of credits back. But I think in Europe, a grid-connected system would be more beneficial because the grid is really stable throughout Europe. So I think a hybrid solution would really work for Europe because solar panels have become a lot cheaper since COVID, and the finances just really add up. So this was the sort of test gear I had set up just at the start of COVID. It's a 20 kilowatt solar array in West Midlands in the UK. We had a Voltcast transmitter, Espresso, connected to a dummy load to simulate like a live world scenario. And we had BYD batteries and Victron system, which is a Dutch system. And the system really performed well. And that just encouraged us that we should copy-paste the solution elsewhere in the world. And so far, so good. It has worked really well in Afghanistan. So I have got 2 sites now in Afghanistan, southern Afghanistan, that are working 24 hours off-grid. And a couple of weeks ago, I was in West Africa, so I took some photos of Sierra Leone site and in Liberia, Monrovia. So the panels are already installed, and I'm expecting this to be ready before Christmas. And this one might be ready in the new year. The internal installation is all done. This is like a 225 kilowatt hour battery storage. But the system that we've designed here is that it's completely off-grid, and it will also be powering an air conditioning unit 24/7. So touch wood, if this works, then we can copy-paste the solution throughout Africa, because in Africa we have quite a significant number of sites. And as we know that in Africa, power is really unstable, and a lot of our money is wasted towards getting fuel for these sites. So this solution will just ensure that we never ever have to think about power outages. So thank you very much.